Hi guys, welcome to my channel. I'm Claire and this is Chem with Claire. Today, the problem that we're going to be solving is the speed of a certain proton is 0.45 megameters per second. If the uncertainty in its momentum is to be reduced to 0.01%, what uncertainty in its location must be tolerated? So let's first highlight the key points of this question. We are given the speed of a proton and how much the uncertainty in its momentum is to be reduced to. And from this, the question is asking us to find the uncertainty in the location. And in this context, location is synonymous with position. Now that we understand what we've been given in the question and what we are looking for, we can recall the Heisenberg uncertainty principle, which includes both the uncertainty in the position and the uncertainty in the momentum in its formula. So this principle was articulated in 1927 by German physicist Werner Heisenberg. It states that the position and momentum of an object cannot both be measured exactly at the same time. In this formula, delta x is the uncertainty in the position, delta p is the uncertainty in the momentum, and h bar is equivalent to Planck's constant divided by 2 pi, where Planck's constant is 6.626 times 10 to the minus 34 joules per second. From classical physics, we can also recall the formula for calculating momentum. So in this formula, delta p is again the uncertainty in the momentum, m is the mass of the proton, which is 1.672 times 10 to the minus 27 kilograms, and delta v is the uncertainty in the velocity. So now that we know these two formulas, the Heisenberg uncertainty principle and the momentum formula, we can sub the momentum formula into the Heisenberg uncertainty principle by replacing delta p with m times delta v. We can also replace h bar with simply h over 2 pi. So now that we have this, we can now isolate for the uncertainty in the position, which is what the question is asking for. To do this, all we did was divide both sides by m times delta v. So now we finally just need to plug in our numbers and solve for delta x. So here I have Planck's constant, which is 6.626 times 10 to the minus 34 joules per second, the mass of a proton, which is 1.672 times 10 to the minus 27 kilograms, and the speed, the uncertainty of the speed, which is 0.45 times 10 to the 6 meters per second, because in our question it gave us the speed in megameters per second, so we changed that to just simply meters per second to follow our SI units. So plugging this into the calculator, we get an answer of 7.01 times 10 to the minus 14. However, we have to recall in the question, it was asking us for the momentum to be reduced to 0.01%. So we have to divide this answer by 0.01%. And when we do this, we end up with an answer of 7.01 times 10 to the minus 10 meters. Now, in order to simplify our units, we can recall that 1 nanometer is equal to 1 times 10 to the minus 9 meters. Therefore, our final answer is 0.701 nanometers. So, using the Heisenberg uncertainty principle and the classical momentum formula, we were able to find the location uncertainty of the proton in this question. That's all for today, guys. Thanks for watching.